Hello everyone, welcome to Finman Flair. Today we are going to learn about logic gates.
At the end of this lecture,
We can easily predict the output of any gate against the inputs by just looking at the symbol of the gates. So these two gates over here can be quite tiresome to remember. So in order to remember these two gates a little easier, we have a little trick up our sleeves. So over here, this is the OR gate. In order to identify this easier, so over here, this is round. So is O in OR. So that is how you can easily identify whether or not this is an OR gate. And over here, the AND gate looks like a D. And A and contains a D in it. Also, you can look at this end over here is not round. Neither is A. So a simple tip to know the output of any logic gate is to just look at the inputs and the output of the gate. So over here, this is an OR gate, obviously, because this end is round. So output Q will be over here. It has no bubble. So it means output Q will be a high, which means 1. If and only if input A over here has a bubble. So if input A is low, which means 0. And over here, there's an OR gate. So OR input B does not have a bubble, which means high. Or input C over here has a bubble, which means low. So over here, output Q over here has a bubble, so which means output Q will be low if input A over here does not have a bubble, which means input A is high. And over here, this looks like a D, so we're going to say and input B does not have a bubble, which means and input B is high. And over here, and input C does have a bubble, which means input C is low. So in order to predict the output by just viewing the gate symbols, we have a little trick up our sleeve as well. So over here, this is the OR gate. This Q output will be high if and only if this A input is high or if the B input is high. So any one of these symbols have to be high. And in order to project this Q output over here for the AND gate, the Q output will be high if and only if this A input is high and if this B input is high too. So both of these have to be high. If any one of them is low, then Q is also low. Now these bubbles over here basically make these gates inversed. So over here, this may seem like an OR gate, but because of this bubble over here, this OR gate has become a NOR gate. So this is basically going to be inversed. So output Q will be low if and only if A is high or B is high. So it's basically the opposite. Similarly, over here, this AND gate has a bubble at its output. So this will be a NAND gate, not AND gate. So output Q will be low if and only if input A is high and input B is also high. So it's also practically the opposite. And over here, this gate is a little different. Over here, you can see its output Q has a bubble, but its input B also has a bubble. So basically, output Q will be low if and only if the A input is high and the B input over here, the bubble represents low. So and B input is low. Similarly, over here, this OR gate has two bubbles at its inputs. So basically, output Q will be high if and only if the A input over here, the bubble represents low. So if and only if the A input is low or if the B input is low. So in order to remember the outputs a little easier, we have prepared a little truth table for these gates. So over here, let's do a little recap. Output Q will be high if and only if A is high or B is high. The output will be high if and only if the A is high and the B is high too. So over here, the truth table for the OR gate. Let's see. If the A is low, the 0 represents low. If A and B are low, then the Q will be low. So over here, the A is low, but the B is high. And we need only one of them to be high. So over here, the output is high. And similarly over here, we only have one high, so the output is also going to be high. And over here, we have double high, so the output will be high. And for the truth table, for the AND gate, we'll have over here, the A is 0, and so is the B. They both are low. So the output will obviously be low. Over here, one of them is low and one of them is high. But we want both of them to be high so that the output will be high. So obviously this is going to be low. Over here, it's similar. We need both of them to be high. But only one of them is high. So the output will be low. Over here, both of them are high. So the output will be high. So over here, these are the truth tables for these weird gates. So over here, output Q will be low if and only if input A is high and if B input is low. Over here, the output Q will be high if and only if the A input is low or the B input is low. Over here, both of them are low for this weird AND gate. So over here, obviously, this is going to be high. Over here, this is low and high. But the input A is high, and so this is going to be high. Over here, A is high and B is low, so this is going to be 0. And over here, this is going to be high. Over here, these two are going to be, make it high. Over here, this is also going to be high because there is a low over here. Over here, there's also so there's going to be a high. And over here, both of these are high, none of these are low, so the output will be low. So that is the end of this lecture. Thank you for learning with me till the end of this video. If you found this video helpful or even educating, then please consider subscribing to this channel. Probably hit the like button or share it to other people so we can spread the knowledge. So for now, bye.